All right, welcome everybody. Today we are going to talk about lesson number 49, and we're going to focus specifically on the graphs of the sine and cosine and some of the transformations that they might undergo. If you'll remember, in the previous lesson, 48, we went a little bit deeper into all 6 trig functions and analyzed them in a couple of different ways. All of the transformations that I'm going to show you today do apply to all 6 trig functions, but we're going to spend some time with just the easy ones, sine and cosine, and then we'll go ahead and extend upon those rules to the harder functions later. So whenever I ask you to graph a trig function, which I'm going to do a lot of, I am always going to ask you to use what's called the 5 key points. So anytime you make me a graph, you have to show me what happens to the 5 key points. And of course, if you're going to do that, you have to know what the 5 key points are. So if we take a look here at the top, notice that on the left, I have a little unit circle there highlighting the quadrantals, and then I have a little axis. So you should, of course, fill in your notes as I go through. We are going to start our axis at 0, and then we are going to end our axis at 1 full revolution around the unit circle, also known as 2 pi. Then, of course, halfway between 0 and 2 pi, that would be pi. Halfway between 0 and pi, that would be pi over 2. And then halfway between pi and 2 pi would be 3 pi over 2. Now, just something to point out, you should, of course, try to draw your tick marks so that they are equidistant, although, a little bit of estimation is fine. Secondly, not only did I kind of have to know that those were the values because I know the quadrantals, but I'm also using the idea of a midpoint. So just to kind of make sure you understand what that means, if I was to add the 0 and 2 pi, the way you would take the midpoint is you add the ends and divide by 2. So 0 plus 2 pi is 2 pi, half of 2 pi is pi. Then if you were to add 0 plus pi is pi, half of pi is pi over 2. Then if you were to add pi plus 2 pi, you would get 3 pi, half of which is 3 pi over 2. So that idea of finding a midpoint is going to be really, really handy once those values are no longer 0 to 2 pi, because in a couple of minutes they won't be. But to start, now that I have my x values set up, I want to also consider my y values. Hopefully, of course, you remember that whilst on the unit circle, the length of the radius is just 1 unit. So if you remember from the domain and the range, while the domain goes on forever, the range is only going to go between -1 and 1. So I'm going to go ahead and mark those off on my y values. We're going to go ahead and start by graphing here at the top, y equals the sine of x. And again, just to be clear, you already know what this graph is supposed to look like, but I just want to be absolutely sure that you know what the 5 key points are, not only algebraically, but what they actually represent. So in order to graph the sine wave, as a reminder, we're going to go around the quadrantals and we are going to graph the y values. Why are we doing that? Well, because sines are y values. So starting at 0, the y value is, of course, 0. Then at pi over 2, it's 1. Pi goes back to 0. 3 pi over 2 goes to -1. And then 2 pi goes all the way back to 0. Once you have those 5 key points, you're going to go ahead and connect them with a nice, smooth, rounded, continuous curve. You want to make sure that your sine waves are, again, always nice, smooth, continuous curves. Now, again, this sine wave technically goes on forever. I could graph as many cycles of these as I want, both in the positive direction and in the negative direction, but we're mostly going to focus on what's happening between 0 and 2 pi and how might that change given a transformation. The fact that it takes exactly 2 pi units to go through the cycle, that means that the period is 2 pi, and I'm going to use p for period for short. So those are the 5 key points, but now let me just again clarify them both with ordered pairs and also with their names. So over here, this is the point 0, 0, and I want to make sure you understand that that is one of the x-intercepts. So I'll say int for short for intercept. Then there's pi comma 0, that is also an intercept. And then 2 pi comma 0 is my third intercept. So 3 of the 5 key points for the sine are those intercepts. Up here at the point pi over 2 comma 1, we want to refer to that as the maximum. And then down here at 3 pi over 2 comma -1, I'm going to refer to that as the minimum. So whenever you hear me refer to the 5 key points, these are the 5 key points that I'm talking about. Again, not just in terms of their actual ordered pairs, but also in terms of the vocabulary. So now that we know exactly what the sine wave is supposed to look like and exactly why, let's go ahead now and do a similar exercise in terms of finding the cosine wave. So notice here, I have another little axis for myself, and I have another fresh copy of the quadrantals. So again, I'm going to start by indicating that this is 0 to 2 pi. Of course, halfway between 0 and 2 pi would be pi, pi over 2, and 3 pi over 2. And just like the sine wave, you are going to be oscillating, a little bit of a fancy word there, between -1 and 1. And again, this is the cosine. Hopefully you remember that in order to graph the cosine wave, you're going to go around to those 5 quadrantals and you are going to graph the x values. That's the definition, the x values. So we're going to go ahead and start at 0. So at 0 radians, the y value is 1. So I'm going to start at 1. Then at pi over 2, it has a value of 0. At pi, it has a value of -1. 3 pi over 2 goes back to 0. And then 2 pi goes back to 1. As you connect these points, again, you want to make sure you have a nice, smooth, continuous curve that looks exactly the way that I've drawn it there. It's kind of U-shaped. Then we're going to go through and we're going to go ahead and label, again, those 5 key points. So starting here, this is the point pi over 2, comma 0. This is the point 3 pi over 2, comma 0. And those would, of course, both be intercepts. Then up here at the point 0, comma 1, that would be the maximum. Down here at the point pi -1, that would be the minimum. And then up here at the point 2 pi, comma 1, that would, of course, be the maximum. So very important that you know what the curves look like. And again, that you focus on the 5 key points. Just like the sine wave, the period is how long it takes to go through one full cycle. And again, the period is exactly 2 pi. You could go around as many times as you want, but we're going to focus mostly on 0 to 2 pi. So now that we've really driven home the 5 key points of the sine and cosine wave, you might be thinking to yourself, well, those two graphs look pretty similar. Is there a reason for that? And the answer is yes, absolutely. You'll recall that if we go through these 4 points of the quadrantals, you only have a handful of values, 0, 1, and -1. The way that we graphed each the sine and the cosine, if we were to just start pi over 2 earlier or pi over 2 later, you would wind up getting the same exact values. So if you kind of look over here on the right, you'll see the sine and the cosine wave on the same set of axes. You can see that the sine wave clearly starts in yellow at 0, 0, goes all the way up, all the way down, and then would terminate after one full cycle at 2 pi. Then, of course, if you look at the blue cosine, you would start at 0, 1, go all the way down to -1, and then terminate up here at the point 2 pi, comma 1. The truth is that when you have more than one cycle, which obviously you have here, the graphs can start looking very similar. And basically, if you were to take the cosine wave, and if you were to move it pi over 2 units to the right, it would wind up looking exactly the same as the sine wave. Similarly, if you were to take the sine wave and move it pi over 2 units to the left, it would look exactly like the cosine wave. You could move it even farther to the left or even farther to the right, and eventually those curves are going to kind of look identical. So that's something you have to be really mindful of when you're given more than one cycle. Is it a sine wave or is it a cosine wave? And sometimes it's both. So we'll get into that more in depth as we go through the next couple of lessons. Something else I want to point out, so at the bottom here, notice that it has not only the radian measurements, but it also has the degree measurements. So I would say 98% of the time, you're going to be asked to graph in radians, but it is important to know that I could ask you to do it in degrees. The truth is, for whatever reason, we don't really ever do that. So you really should be in radian mode as far as all these problems go, not necessarily on your calculator, but in your brain. So I want to go back now and kind of give you a little bit more vocabulary. I've given you new copies here to write on. You're welcome to just write these on the graphs you've already drawn. I just wanted to have fresh ones so that I didn't make a big mess. So over here on the left, what we have is what looks like a sine wave kind of floating out in space, but because of what I just told you, there technically could be a cosine wave in there as well. So really, I left it vague on purpose. So a couple of vocabulary words that are going to be very, very important. So first, if you look at this purple here, this is showing you the distance from this ordered pair to this ordered pair. Hopefully you remember from earlier, that is what is defined to be the period. The period is the length of one full cycle. And remember, that's either a full cycle of the sine wave, which this appears to be, or a full cycle of the cosine wave. Then notice you have this pink dotted line that runs through the middle of the graph. And by middle, I mean the middle of the y values. We are going to call that the midline. And this is basically the line, let's say the horizontal line, that cuts the y values in half. Then you'll notice you have this dotted line here in green, and you also have another dotted line here in green. We are going to refer to that as the amplitude. And the amplitude has a couple of different ways to describe it. The first way you could describe it is the amplitude is a formula, and that would be the maximum minus the minimum divided by 2. Probably an easier, a little bit of a friendlier way that we're going to use it is it's the distance from the midline to the max or to the min. So both of these here are considered to be the amplitude, whatever the distance was going from the midline up, and then whatever the distance was going from the midline down. So again, important to kind of know those new vocab words since I am going to be using them. So let me go ahead and highlight those for you. Again, notice here we're just giving them a general definition. They will eventually be numbers, but for now we just kind of want to know them in general. And then again, you don't necessarily have to write all these down, but I just want to show you over here. So this is an actual algebraic example. So notice that when we're talking about a period, again, that's the distance of one full cycle. What you'll kind of notice here is that if you were to highlight what they're saying the period is, that actually isn't a sine wave. It's a negative sine wave, which we're going to talk more about those transformations in just a second. But regardless of whether it's positive or negative or whether you've moved it around, the period is always the distance from the start to the end in terms of the x's. Then notice you have the midline that's cutting the y values in half. So hopefully you notice your highest y value is 5, your lowest y value is 1. So the midline has to go through the middle. And of course, the middle of 1 and 5 would be 3. Then notice that the amplitude is the distance from the midline to the top or the midline to the bottom. So that would be exactly 2 units, whether you went up or whether you went down. So again, very important that you know these general vocab words. And now we're going to kind of put them into action. So again, in terms of the graphing, I have copied just kind of a nice a nice fresh curve each time so that I could use it as a reference. You don't have to do that. You can just kind of write down what I write down from this point forward. So, don't feel like you have to write down every single thing. So we're going to go ahead now and start talking about the changes that we can make to the sine and cosine. So we're going to go ahead and start with the easiest one first. So here are the first changes that you can make to a graph. You can take the sine wave and you can change it into y equals a times the sine of x, or you can write a times the cosine of x. It would work the same for sine or cosine. So what I want you to realize here is that if you're talking about this a value, what this is doing is this is making a change in amplitude, which again, we just defined above. When you're talking about a change in amplitude, you're talking about a vertical stretch or shrink. Hopefully you remember back from all your transformation lessons that if you're doing a vertical stretch, or shrink, that would be known as a y change. So whenever you have a number other than 1 out front, that means that there is a change in amplitude. Either it's going to be something larger than 1, which makes it a stretch, or it's going to be something smaller than 1, which is going to make it a shrink. And again, you are going to be making that stretch and shrink vertically, which means you're going to be making a y change. So keeping that in mind, again, you don't have to redraw this sine wave. I only did so that we could use it as a reference. A couple things to just point out, again, about this parent function. The period of the sine wave starts at 0 and ends at 2 pi. The midline is 0, cuts the y distances in half. And then the amplitude, which is the distance from the midline up or the midline down, the amplitude is 1. So that is the starting period of, or the starting amplitude of the parent function is just 1, just like the starting period is 2 pi, and the starting midline, which is actually d, is going to be at 0. So all those things are subject to change. Here we're going to talk about changes in amplitude. So what I would like you to graph, and again, this is where you should start writing these down. So here in number 1, instead of graphing the sine of x, I would like to graph y equals 4 times the sine of x. So if you notice here that the fact that there's a 4 out front, that is what indicates that I'm going to have a change in amplitude. The fact that there's only a change in amplitude means I'm changing the y values, but I am not changing anything about the x values. So I'm going to start by making myself a scale here, and I'm going to keep the x values the same. So from 0 to 2 pi, pi in between, pi over 2, and 3 pi over 2. And yes, you do have to label them every time. Because of that 4, that means that I'm stretching an amplitude that normally would be 1 to 4. Now, you can draw this to scale if you want, but I'm just going to label 1, 2, 3, and 4. And then I'm also stretching in the negative direction down to negative 4. Here's the thing. A lot of your graphs are going to wind up looking very similar. If you were to actually draw each of these to scale, it just takes up a lot of room on your paper. Again, you're welcome to do that if you want to, but really no need. As long as you have them correctly labeled, that's really all that's going to be important. So you're taking the sine wave, the parent function on the left, the x values are staying exactly the same, and all you're doing is stretching the amplitude by 4. So keep in mind that any points that are on the x-axis with a value of 0, those are actually going to stay exactly where they are. The maximum, instead of having a y value of 1, is going to stretch up to 4, and the minimum, instead of having a y value of negative 1, is going to stretch down to negative 4. So in the future, later today and for homework tonight, when I say graph using the 5 key points, this is what I mean. Tell me and show me exactly where the 5 key points from the parent function would move under the transformation. You don't have to label them, although you can if you want to, as long as you have the x and y's labeled, and I can tell, that's perfectly acceptable. So amplitudes bigger than 1 are going to be stretches, and amplitudes smaller than 1 are going to be shrinks. So questions? Okay, so now that we understand what an amplitude does, let's go ahead and take a look at the next change. So the next change that can happen is you can have y equals the negative sine of x, or you can have y equals negative cosine of x. What these transformations are is they are reflections over the x-axis. Hopefully, again, from your transformation days, you understand that a transformation over the x-axis is, of course, a y change. So again, you don't necessarily need a fresh copy, but I've gone ahead and drawn one for myself, just so I can show you exactly what's happening here. So notice this time we're talking about a cosine. And what I want to do to highlight the change here is I want to go ahead and graph y equals the negative cosine of x. So again, I'm going to start by drawing myself a little scale here. Because of the fact that this is a y change only, again, my x's are the same from 0 to 2 pi, halfway pi, pi over 2, and 3 pi over 2. Are those ever going to change? Yes, just sit tight. So here, there isn't necessarily a change in amplitude. The only difference here is that you're going to have a reflection. So that means that any values that are above the x-axis are now going to be below, and vice versa. So again, because there's no change in amplitude, I'm still looking at 1 and -1. If I now go to make my transformations, again, anything that's on the x-axis is going to stay exactly where it is. So pi over 2 and 3 pi over 2 are not changing. Instead of the graph starting up at +1, it's going to start at -1, which means it's also going to end at -1, and then it's going to go up to a maximum of 1 in the middle. You're going to go ahead and draw your nice, smooth, continuous curve, and notice that really the only difference between the cosine and the negative cosine is now you have a graph that's upside down. If you're thinking to yourself, can you do more than one change at a time? Absolutely. So let's over here talk about number 3. What if I asked you to graph y equals -1/2 sine of x? So if I'm asking you to do -1/2 sine of x, you're doing both of those transformations at the exact same time, and that's perfectly fine, twice the fun. So again, there are no x changes, so you're going to go ahead and leave those the same. Again, whether you draw these to scale or not, it really doesn't matter. And again, please be mindful that these are two different transformations. This negative is what reflects it over the x-axis, and then this 1/2 is a change in amplitude. While you can certainly do them both in one step, you still do want to understand that they are two separate transformations. So let's say that I make this one, and let's say that I make this -1. Again, if you kind of want to draw it to scale, this would be +1/2, and this will be -1/2. I personally don't really care whether they're to scale or not, so don't do that on my account. So again, the sine wave normally starts at 0, 0, and anything that's at 0 is going to stay. So stay here, stay in the middle, and stay at the end. Normally, the sine wave has a maximum of +1, but because of the fact that you're changing the amplitude to 1/2, and then you're reflecting it over the x-axis, you're actually going to have that point there at -1/2. Then the sine wave usually has a minimum of -1. If you change the amplitude by 1/2, that would be -1/2. And then if you reflect it, it would be +1/2. So your -1/2 sine wave is actually going to look like the following. So the graphs are going to kind of look, very similar in the end if you're not drawing them to scale. But again, that's fine with me as long as you have the x and the y-axis correctly labeled. So the last change that we're going to talk about today is we're going to talk about a change in period. So in order to discuss a change in period, we're going to consider what would happen if you had y equals the sine of bx, or if you had y equals the cosine of bx. If you haven't noticed, each transformation is going to be a letter, and we'll get to C and D in the upcoming lessons. So here's what you want to understand about B. What B represents is it's a change in period from 2 pi to 2 pi over B. So when you have a b other than 1, so basically every problem we've done so far has had a b value of 1 because in front of the x has been nothing other than a +1. So when you have anything other than a 1 there, you're going to have a changing period from 2 pi to 2 pi over b. So just to kind of write that a little bit more streamlined, the formula for period from this point forward is going to be 2 pi divided by b. What this B does is it is a horizontal stretch or shrink. And again, back from your transformation days, this is an X change. So far, all we've done is Y changes. So this is going to be your first X change. So again, it's horizontal and it's an X change. And then again, one last thing from your transformation days, anytime you're doing an X change, remember you're kind of doing the opposite. So if you see a number that's bigger than 1, you're actually going to have a shrink, where if you see a number that is a fraction, you're actually going to have a stretch. So now that we know what it is we're talking about, let's go ahead. Move that down a little bit. Hang on. Okay. So now that we know what the changes are, let's go ahead and actually do one. So again, I have myself a fresh copy of the sign of X here. You don't need to redraw it every time. I just think it's kind of nice to see here. So this is going to be number 4. And I'm going to ask you to graph y equals the sine of 4x. So this 4, that is your B. That means there's a change in period, and the change in period happens by doing 2 pi over b, which in this case is going to be 2 pi over 4. If you simplify that, what this means is that your period has changed from 0 to 2 pi and is now going to be 0 to pi over 2. So when I go to set up my x-axis, I am no longer going to start at 0 and end at 2 pi. I am going to start at 0 and I'm going to end at pi over 2. That's what it means to have a change in period. It means you're changing the distance from the beginning to the end. Now, a couple things to point out. Are you always going to start at 0? For today, yes. You're not going to start at 0 when you start pushing the graph to the left or the right, which is actually the last thing we're going to do. So for today, you're starting at 0 every time. Again, because I'm not necessarily drawing it to scale, my 0 to 2 pi on the left kind of looks like the same distance of 0 to pi over 2 on the right. But again, that doesn't matter as long as you're labeling it correctly. So as far as the 5 key points go, you're now going to go back to the earlier strategy I had mentioned about midpoints. Halfway between 0 and pi over 2 means you would add those together and then take half of it. So what's half of pi over 2? That would be pi over 4. When you're taking a fraction and you're dividing by 2, remember that's the same as multiplying the denominator by 2. So pi over 2, half of that is pi over 4. And then half of pi over 4 is pi over 8. Then if you're talking about starting at 0, which again you are for today, whatever this first tick mark is, that's what you're counting in. So this is pi over 8. Then this would be 2 pi over 8, which reduces to be pi over 4. This would be 3 pi over 8. And then this would be 4 pi over 8, which again reduces to be pi over 2. You have to leave them in terms of pies, and you have to leave them in terms of fractions. No decimals allowed. So those are my x changes. There are no y changes, which means I'm still going to be between -1 and 1. And all this means, a change in period, means that instead of you running from 0 to 2 pi, you're now going to run from 0 to pi over 2. But the y values of the sine wave, because there's no other transformations, are going to be exactly the same. So you're going to start at 0. Then you're going to have your maximum at 1, 0 in the middle, -1 for the minimum, and 0 for the end. So it actually looks almost identical to the original. The difference being is that you have a different period. Just to kind of give you a little more information in terms of what that actually means. So what that 4 actually means in terms of being the B is that in 2 pi, you have 4 cycles of the graph. So think about what would happen here if you, instead of going from 0 to pi over 2, if you actually wrote from 0 to 2 pi, you would actually have 4 of those sine waves in total. The first one would go from 0 to pi over 2. The second one would go from pi over 2 to pi, then from pi to 3 pi over 2, and then from 3 pi over 2 to 2 pi. So that 4, in terms of the period, means that you have 4 cycles of the graph. Basically, you are speeding it up. And in terms of transformation words, it's a horizontal shrink. Okay, so now that we understand what it looks like to have a horizontal shrink, let's talk about what it would mean to have a horizontal stretch. So here for number 5, I'm going to ask you to graph y equals 2 times the cosine of 1/3 x. So notice not only am I going to have a B change here, but I'm also going to have an amplitude change, since it is very possible and probable that you're going to have multiple things at once. So maybe you want to note that this is your A and this is your B. So you're going to have both a change in amplitude and a change in period. You should always deal with your period changes first in terms of the setup, because those are a little bit more difficult. So remember, what does that B actually do? It's going to change the period by 2 pi over B. So 2 pi divided by a third. If you're dividing by a fraction, remember that's keep, change, flip. So 2 pi times 3 over 1, which means your period is now going to be 6 pi. So again, while the previous example, you were speeding up, now you're slowing down. Instead of taking just 2 pi to go through a graph, now you need a full 6 pi in order to go through the same distance. So what am I going to do here? Well, I'm going to start by setting up my curve. Give myself a little bit more room. So again, I am going to label my x's first. So starting at 0 and now ending at 6 pi. Halfway between 0 and 6 pi would be 3 pi. 0 plus 3 pi divided by 2 is 3 pi over 2. 3 pi plus 6 pi is 9 pi, half of which would be 9 pi over 2. Or remember, instead, you can just count in 3 pi over 2s. Whatever you need to do to kind of get those 5 key points, that's really the goal here. Then notice that I also am going to have that change in amplitude. So I'm going to make sure that my y values go to 2 and negative 2. Let me just move my period a little bit so I have a little more room. So remember, the period is 6 pi. And I'm going to go ahead and set up my y values to be 2 and negative 2. So this is a cosine wave, which means it's supposed to look like this. I know that there was a period change. I've already taken care of that by changing my x values. Now the 2 on the outside means that I am stretching all of the y values by a factor of 2. So normally the cosine wave goes through 0, 1. Now it's going to go through the point 0, 2. And whatever happens at the beginning also has to happen at the end. Normally the intercepts go through pi over 2, 0, but now it's going to go through 3 pi over 2, 0, and 9 pi over 2, 0. And then normally the minimum of the graph goes through pi negative 1, and it's now going to go through 3 pi negative 2. And I'm going to go ahead and sketch a nice, smooth, continuous curve. Again, to give a little more context as to what the 1/3 actually means, basically this means you need more than 2 pi for a cycle. And in terms of transformations, this would be thought of as a horizontal stretch. So those are all the transformations that you're going to be expected to know today. What happens if you reflect it over the x-axis? What happens if there's a change in amplitude? What happens if there's a change in period? And keep in mind that you can, of course, have multiple changes, which we've seen a couple of, in order for you to actually graph me one full cycle, which is basically what I'm going to ask you for each time. You have to be able to show me what is happening to those 5 key points. So thanks very much for tuning in for your first official lesson on the sine and cosine transformations. So we will catch you next time.